Oh, there's plenty of things that you can Google that will give you disturbing results.
I have a lot of things on my phone. Oh, I have a question.
Search up Shoeless Sonic.
Some music I want for the class. Oh
no. We gotta do some math. If we run out of time, then yes, you can do that.
We should search up Shoeless Sonic.
I'm afraid to type that one in. All right, here we go. Now, I've made this claim that this chapter is a butt kicker, and it is. It kind of starts today. Today is kind of a medium butt kicker, but it's still going to be, for some of you, it's going to be a butt kicker. The way that you keep this from being completely, totally overwhelming is you're going to stop me if you don't see the pattern. Today is about recognizing a pattern and being able to rewrite that pattern. Some of you will catch on like that. And you'll be wondering, why is he making a big deal about this? But I've done this many years. This is where I typically start losing someone. And it's because some people can recognize patterns quickly, and other people look at something and they're like, I don't even know what he's even talking about. Where would there be a pattern? Okay. I'm not collecting homework.
Oh man, I did it for no reason.
No, you didn't do it for no reason. It was just practice. But we're going to start today on the rest. And I said, I think maybe we'll probably have to have practice day. I'm going to leave that up to you. At some point, I'm going to ask, we need a practice day. It's not that you won't have a test on Chapter 7. It's just that I'll run out of time, and I will put it on the semester final. By the way, we've made the final decision yesterday. I haven't changed this. Your first semester final will be on period 7 and 8 on that Monday. I want to say it's your 7th period class. What's your 7th period class?
History.
Art. 7 is art.
So talk to your art teacher and see if they're going to give you a semester final.
Wait, 8th period? That's student essay.
Agreed, but remember, semester final is going to be an hour and a half long. So we need
Excellent.
2 periods to do that. So we're going to take 7th and 8th period on this Monday. That will be your first semester. You got 7 semester finals, 7 classes, 7 semester finals. You're going to have 1 this day, 2, 4, 6. That's total 7, right? And then this is our makeup day. There'll also be some activities that we do this day, but for the most part, this is specifically designed for that Friday where, I was absent or I had an orthodontist appointment. I couldn't take the semester final, so we got to have 1 day for that. Okay?
Because you care about hygiene so much.
Well, yeah, clearly. I'm wearing a mask that's ripping my ears off right now.
I know,
Oh my God, this is painful.
Yeah, I did this.
I got to get something cold in the back.
I saw Mr. Rubiger wearing it, and like his ears were.
My ears are going like this right now. It hurts.
Yeah.
All right. Write this down. Homework.
God.
We will go slow if necessary today when we get to the challenging part. And I'll tell you, hey, this is the challenging part. First part isn't that challenging. Straight up pre-algebra stuff. Okay. Second part is medium. It's not truly the hard stuff, but it is where I typically lose some people. Nothing like crazy, weird concepts that you're looking like, I don't know what he's talking about. But it is involving patterns. No, you're going to see.
Okay. Oh, no.
I did start the video, yes. Yes, I did.
Did you?
I did. Checking right now.
What?
How to read binary?
Well, I guess more.
I can show you at least some easy stuff.
I did binary in like 6th grade and I forgot everything.
I have one problem
Put a 2 in the binary.
No, you're a mistake.
Let's.
Okay.
20.
No, it's 100 in binary.
Oh, see, that's the, I haven't done binary in such a long time.
This is actually the number 2, and that's the number 2, so that's the number 4 in binary.
I can't agree.
Oh, wait. Okay, hold on.
Remember?
You're not gonna get it.
The first digit is
I'm trying.
Is either 0 or 1. The second digit is either is a 2, and the third digit is a 4.
Okay. Hold on.
So if you want to write the number 3 in binary, there's 3. That's a 1 plus a 2. That's a 3.
And then what's a 1? Is it
A 1 is a 1.
What's a 1? And what's a 0?
A 0.
But that's a 2.
63.
We're talking about the first column. It only becomes, it's a base 2 system. All right. Enough of the tangent. I've already confused some people and they're not paying attention. All right, here we go. Properties of proportions. You've dealt with proportions for many years. These are going to be, today we're just going to do, there is a little bit of homework involved as a triangle and some proportions. It'll be self-explanatory. But we're not going to see any shapes today at all in the class. All right, where we left off, 7-1 is where we left off, is we were introduced to ratios, right? Well, a proportion is you take two ratios, squeeze them together, you put an equal sign. Write this down. Oh, I didn't hand out the sheets. Oh, yeah, I did. You didn't get one? Everybody else got one, yes?
Yeah.
Connor, you got one? Okay. So proportion. Just two ratios with an equal sign between them. All right, there you go, boom. Like I said, you've seen this probably even before pre-algebra. 5th, 6th grade, I think this is initially introduced to you. Remember proportions, if you take one of the fractions, like 4/6, and you reduce it, you get to the other fraction. All right, nothing special about that, stuff you've already seen. Remember, we can write ratios in colon form. So if I write this proportion in colon form, 4/6 is the same as 2/3. Okay? Now, here comes the first, I might lose you. Okay? It turns out we give names to the positions when it's in colon form. You with me?
Yeah.
We're going to give names to the numbers when it's in colon form, a proportion. So write a proportion in colon form, I give names to these numbers, the positions. So I got first position, second position, third position, fourth position. Everybody with me? Nothing confusing there, but I'm giving names to those. Okay? An extended proportion, that's what we saw in section 7.1. That's when you have 1 to 2 to 4, right? You have three ratios put together. So what would that look like? Well, it would look like in fraction form, it would look something like that. So I got an equation, right? Because I got an equal sign. We got more than two ratios are equal. Now I stopped at 3, but this could go on for a long time. Danny, you writing this down? What? We're on box 1 still. Extended proportions. This is what that concept we were introduced in section 7.1, where you had, three ratios equal to each other. That was the homework that we had, where they had the triangle, and we said they're in a ratio of 2 to 3 to 4, and you had to solve for it. We write that in proportional form, we get what's called an extended proportion. It's still the same basic idea, right? You still have fractions that are set equal to each other. In colon form, it gets kind of messy. Bless you.
Bless you.
Hand sanitizer.
Go ahead, go get some hand sanitizer. Elbows. You'd be too careful nowadays.
Okay, we all right with all this so far? All right,
Yeah.
I'm moving on. Next slide. All right, so here we go. Box 2. Here comes where the pain kind of semi starts.
Yay.
We're going to give names to these positions. I remember distinctly getting this class, and I actually got first in Algebra 1. Our book chooses to introduce this to you in geometry. I remember the teacher saying this stuff, and I was like, okay, that's simple, but I didn't really pay attention. And then came test day, I was like, well, I forget which one means what. This are just names. We've got position 1, position 2, position 3, position 4, and they're just names. Position 1 and form get a special name. You need to write this down. Position 1 and position 4. Now notice, I've given you both in fraction form and in colon form for these proportions. Position 1, okay, well, it's right here. Position 4, it's right here. Position 1, position 4. We call those positions, we call those the extremes. They're just names. I didn't get to pick the names. I would have called them position 1, position 4. No one would be confused. But they're called extremes. Why are they called extremes? Because in colon form, notice, they're on the far outside. This is what my math teacher never showed me. She just showed me the fraction form and said, these are called the extremes. Okay, so the numbers on the outside in colon form are called the extremes. I don't know where they got the word extreme from. I mean, it kind of makes sense in colon form because they're on the outside.
Just nerds trying to like.
I think so.
They're just like, oh, I'm gonna be extreme.
Yeah.
The most extreme
All right.
realize.
Position 2 and position 3 get a name, sorry. They get the name. Those are these ones. Positions 2 and position 3. But okay, when I'm saying position 2, position 3, I'm just saying the middle terms right here. They get a name. They're called the means.
To an end.
They are the inner terms if you write it in the colon form. In proportion form, I don't know how you want to describe them. Like I said, this is where I kind of, because my math teacher only showed me proportion form, and I couldn't tell the difference between a mean or extreme. In colon form, it makes a whole bunch of sense. The extremes, okay, outside, means inside. Also, the saying, and it's in every single math book I've ever read, the saying I'm about to say, instead of saying the extremes and the means, they say them the opposite. They'll say the means and the extremes. They're not confusing what I just showed you. They're just choosing to use the word means before the word extremes. You'll see here in a second. Every single math book I've ever read always says the means and the extremes. They don't say the extremes and the means. I think that's why I was always confused. Because when I look at the proportion, I absolutely think about this number and that number first. These are actually called the extremes. These are called the means.
But they start with the means, not the extreme.
Say what?
But they start with the means, not the extreme.
Yeah, don't ask me. I have no idea why. I have no idea why they always say means and extremes instead of extremes and means.
It doesn't matter, does it?
It doesn't matter as long as you understand their position.
Just
And
means-
they are just names, by the way. There's nothing mathematically significant about the means or the extremes. There is something significant about the relationship between the two, though.
No.
All right, it turns out, right, you guys have seen this before. Anybody want to take the leap of faith and tell me what do you know about the means and extremes in proportion form?
I'm going to take a leap of faith. You can times the extremes.
The products are equal to each other. In the products, the extremes multiplied together, 4 times 3, is equal to the means multiplied together. You've learned that way a long time ago. And that's why this saying, they'll say the product of the means is equal to the product of extremes. That's where I got confused.
Getting started like
All right. So box 3, please. In a proportion, the product of the means are the blue ones. The product of the means equals the product of the extremes. Always. This is what you've known as for at least the last 3 years is what? You didn't learn it as the product of the means equals the product of extremes. You learned this as, what did you call it?
I just did it.
Yeah, but what did you call it when you were doing it? Your teacher probably said something like this.
I haven't teacher.
We just called it cross multiplication, right? So why can't it be called cross multiplication? Because some mathematician said we're going to call it the product of the means and a proportion equals the product of the extremes. Yeah, most of us remember this as cross multiplication. Half of what we're doing today is cross multiplication. That's the easy part. I don't need to give you a class on that.
No.
But I will. But you should walk into a geometry class already knowing how to solve a proportion. But I will still show you a couple examples. Some of the examples are hard, challenging. We'll save that to the very end of class. But this is stuff that we already know. You can always cross multiply if you have a proportion. Remember, proportion is 2 ratios equal to each other. All right, we okay? Let's just do a couple quick ones. Get it? But why? All right. But why? I mean, a teacher just told you a long time ago, hey, it's cross multiply and it works. Did they ever prove to you why it works?
No.
I mean, you accepted it as being true. We're in geometry class. You can't accept anything in geometry class. So I got to prove it to you. I got to prove that when you cross multiply, you will get an equality. The proof is actually pretty easy. Watch me do it. Right? I'm not having you do it. Hey, I got an equal sign. Are you allowed to multiply both sides by the same number if you have an equal sign?
Yes.
Sure. So I'm going to choose to multiply both sides by b. You said I can multiply by anything. I'm going to multiply by b.
Why?
Well, you're going to see why here in a second. What happens on this side? You're left with that. Now I'm going to choose to multiply both sides by, you said I can multiply by anything. I'm going to choose to multiply both sides by d.
I was sure just getting rid of like all the common.
What happens?
No,
So what are you left with?
B times A equals C times B.
And I'm just going to choose to write them in a different order, but it's still a d times a is the same as a times d. So I get a times d, and there's your cross multiplication. A times d is the same as b times c. I just proved it to you, by the way, algebraically. But that's why you're allowed to cross multiply. Cool. The product of the means, this is where I lost it. Product of the means equals product of extremes. When I look at this, I'm thinking a times d equals b times c. That's the product of the extremes equals the product of the means, but it's never said that way. So there's my cross that I died on in Algebra 1 and geometry. All right, so what? Well, it ends up being that you can solve proportions where you have an unknown very easy using cross multiplication. Connor, what do you want me to do? Product of the means equals the product of extremes. So therefore, say it, cross multiply. What did you say? Equals. Continue down that path. You're on the right path. Don't overthink it. Just say it. Okay, so he said the product of the means equals the product of extremes. So he said 2 times 15 is equal to x times 5. I'm just going to choose to write that as 5 times x. And you can kind of see why. Connor, 2 times 15. Double it. Take a guess. Is it 50? Is it 10? It's probably somewhere between 10 and 50. 2 times 15 is 30. All right, algebraically, what do I do? Last step, and then I'll stop bugging you. Okay, so we divide both sides by 5, get x equals 6, okay? This is something you did in pre-algebra, right? This also was the extent of the complexity of the ones that you did in pre-algebra. And you want to have a problem, and they're like, I've never done that before. I don't know what you did right there. Okay, so do box 4, please, all by yourself. Get to the answer, box 4. Some of you could probably do this in your head. Others of you need to write out all the steps. Wes says I can do the whole thing in my head. The first one, sure. Oh, wait, the math is ugly. Yeah, you're not going to get nice, friendly answers in geometry. Don't change it to a decimal. Leave them as a fraction.
So do I just
Reduce the fraction and call it a day.
okay?
Yeah.
What if I'm using a calculator and it just gives me a decimal?
Well, I'm just saying that you're going to be, when I call out the answers tomorrow for homework, they're going to be all in fraction. I'm not going to give you any decimal answers.
Okay.
Just leave them as fraction. By the way, your calculator, I've shown you the button, yes? Have I?
Imagine.
Do 7 divided by 10 on your calculator right now. What's 7 divided by 10?
0.7.
Hit the math button on the left side. Hit 1 for fraction and hit enter. So what's,
7/10.
see? You know how to use your calculator, then the calculator will tell you everything.
Even where the Holy Grail is.
If you program it, I guess. It's in Nevada, north of Las Vegas, Area 51.
Along with all the other
SCP.
things.
Imagine the Holy Grail is an SCP.
According to Raiders of the Lost Ark.
I mean, it does heal people. I mean, that's probably easy.
I think they're coming out with another Raiders of the Lost Ark.
Yeah.
How many Indiana Jones have we used?
4? Chris, you done?
Yeah.
What you get for first one? Final answer.
You're
What?
confused on more time.
Well, you just told me you did.
If you
Don't lie,
divide
please.
11
All right, Chris, walk me through the first one. Tell me what to do.
or 15.
So what should I do?
Equals 14.
That's
So
4x.
it's 14.
You talking?
And 11.
That's 50. So I get 4x equals 50. Last step. By 4. So that can be reduced to, some of you I know really wanted to put it in decimal form, so you put 12.5. But you could have written that as 50 over 4. In other words, 25 over 2. 25 over 2 is a perfectly fine answer. For those of you that I can't convince to leave it as a fraction, then you put 12.5. Wes, you got the last one?
No, I didn't.
All right, tell me what to do.
I'll multiply 2 by 5.
Do what?
Multiply 7
7x. That's 10. So I get 7x equals 10. I wrote it in the opposite order. Last step.
Divide both.
I get 10 sevens. Tonight for homework, you're going to have much more challenging ones than these, but this is the basic idea of solving proportions. Is everybody okay? We're going to save the more challenging ones. They're just more challenging algebraically to the very end. But we're going to use this concept of proportions can be solved in our next concept, which is the ugly one that I want to spend the most time on. Tonight for homework, they're going to give you just the same thing, 2 proportions or 2 ratios set to equal to each other. They're just going to give you some uglier numbers. And I don't mean like it's going to be 254. They're going to give you some more variables. You'll see here. All right. So the challenging stuff starts right now. Now is where you got to super pay attention. All right. So check this out. If I have a proportion, Danny, eyes on the board. If I have a proportion, right, we found that through a little bit of algebraic manipulation, we can get that the cross products are equal to each other. A times D is equal to B times C, right? I got from here, if I'm given this, I can get to this. Turns out there's 3 other ways of writing this proportion. There's 3 other ways. How do you get to those ways? You just use a little bit of algebra on the original proportion. Okay? So I'm going to take this original proportion over here, do some more algebra. Last time I multiplied by B and D, well, this time I'm not. I'm going to multiply by something else, right? I'm going to multiply both sides by C. Okay? Except I'm going to not write C, I'm going to write 1 over C. You'll see why here in a second, pun intended. All right. So if I multiply both sides by 1 over C, I'm not telling you why I chose that number, but I can choose any number I want. Let's see, the C's would cancel over here. And over here, you'd be left with A over CB, sorry. Then I'm going to do the same thing. Instead of multiplying by C, I'm going to multiply by B. Once again, I just chose that. Over here, the B's would cancel. And you would be left with A over C is equal to B over D. And I just did a little bit of multiplication. I changed the order. Notice this now doesn't look like this. Somehow it's the same proportion. So let's see what the pattern is. You ready? I said today's about identifying patterns. Danny, eyes on the board. You've got to identify the pattern. Notice it still says A times D equals C times B. A times D equals C times B. It's still the same proportion, just in a different form. Well, let's see what the pattern is. If this is what you started with, I got A over B, but now I have A over C. So in other words, instead of being A over B, it's this over this. Well, if that's the pattern, you're with me? This is how you identify the pattern. If this is written A over C, then the other ratio must be in the same pattern. I went from left to right. So the other proportion must go from left to right. If I go left to right, look, left to right, left to right. The other one must also go left to right. So the other ratio must be B over D. And by the way, there it is. That's the pattern. The pattern was top over bottom. Now turns into left over right. So I take the second one and do the same thing, left over right. Left, right. See what it is? There's 4 of these that you got to memorize. So you're lucky you're in my class because I don't make you memorize anything. We're just going to write them down. By the way, I just proved this one. The other 3, you proved tonight for homework. All right, so it turns out there's 5 total, but there's 4 that look like this. You got to write these down in your book of truth. Okay? There's 4 different ways of writing this proportion. So in your book of truth, you have to have this in your book of truth. Here we go. Book of truth. If you're given this original proportion, Danny, in your book of truth, if you're given this original proportion, there's 4 ways of writing it. The first one is easy. It's just the cross multiplication products. In yellow is what you're going to write. Write this at the start. If it looks like this, you're also allowed to write it like this. We proved that one. We just proved this one. The other two we didn't prove. You're going to prove tonight for homework. I'm sorry, the other three. Danny, pencil, move, make it work. This is how you do your homework. If you're given this original proportion right here, you can, if you choose to, write it like this or like this. And here's the other two that I didn't prove to you, but you'll do it tonight for homework. It can look like that, or it can look like that. There's 4 of these. Why do we need 4? Well, I'd say the basic reason why we need 4, we don't need 4. We only need 1. Well, the blue is perfectly fine. But the other ones give us more options. You'll see tonight when they have you solve for an unknown variable, is that using one of these other options actually allows you to get to the answer very quickly. So what's the reason behind this? Why we would care about this is because it allows us to get to an answer easier than in the original form. Tonight for homework, they're going to give you, well, you'll see here in a second, they're going to give you a proportion. It's going to look like this. And then they're going to give you a second ratio and ask you to rewrite the third ratio. You'll see here in a second. How you're going to get to the answer is you're going to look at these patterns right here in yellow. The next 2 examples on your sheet is when we're going to do these, or next 4. I gave you 4 examples. Now I did say there are 5 of these. These are 4. So if it looks like this, it can also look like any one of these. This last one here is the only one that needs a little bit of explanation. How do you get this? Well, what they're really doing is adding 1 to both sides. Or d over d is 1, d over d is 1. So they're just adding 1 to both sides. We proved the first one, we proved the second one, you will prove the third and fourth one tonight for homework. And there's 1 more of these. I said there were 5 total. The 5th one doesn't start with this, it starts with a different form. Okay, also in your book of truth, write this. It gets this old page to itself. If it looks like this, that doesn't look like the previous one. The previous one just had 2. If you have more than 2, ... means it could go on forever, right? But what it's really saying is if you have more than 2 ratios set equal to each other, so if you have one of those complicated proportions right here, extended proportion as we called it, then you get this. It says that you can take all the numerators, add them together, and put it over all the denominators, put it together, and that's supposed to equal the original a over b. It also has equals ... It means it could equal a over b, or it could equal c over d, or it could equal e over f. This one's the most complicated one to kind of wrap your head around. But all it really says is take all the numerators, add them, take all the denominators, add them, and whatever the answer is, well, it's going to equal that first ratio, a over b, or the second one, or the third one, or the fourth one. Here's not a proof, but here's an example. If I took 1/2, that could also equal, give you another ratio that's 2/4, and that could also equal 3/6. So it turns out that if we take all of these numerators and add them together, 1 + 2 is 3 + 3.
6.
And if we add all the denominators, 2 + 4 + 6, 12 and 16. Turns out we get a half. Kind of crazy, right? That's all it says. Now that's not a proof, that's an example. Okay. So we get 5 of these things. Like I said, this is the challenging part. We get 5 of these things. They got to be in your book of truth, and you got to look them over. We're going to do 4, just 4 examples. We probably need to do 24 examples to get everyone on board. Some people will catch this really quickly, but it's painful for other people, right? Painful. That looks painful.
That looks fake.
So here's what homework will look like, the hard part of the homework. Each part is just solve a proportion. Notice I got 2 variables here. So here's how it's done. You paying attention? So you're going to take the original one, and they're going to give you an example ratio, right? For example, they may say this and ask you to fill in the blank. Or they'll give you a proportion that will have question mark over question mark. What they want you to do, is everybody paying attention? What they want you to do is compare these 5 that I just gave you to the original one and the question. It's complicated. They want you to compare the original one to the question and match it to one of these 5. Here's the original. Here's the answer. It's going to match one of these 5. What form does this look like? The first one, the second one, the third one, the fourth one, and the fifth one? You're saying that this looks like this.
I mean, theoretically, you can write an equation.
No. I'm saying this looks like this, yes? Doesn't this look like this? We're just missing something. So what they're really trying to do is match this one to this one. Now, I highlighted another thing because you got to wrap your head around that. This is where this comes from. This says A times D is equal to B times C. That's the pattern. So we're going to follow the same pattern with this one. So if that's the pattern, then this times this equals this times this. So 5 times y, which is what this says. Now follow the pattern what they gave me. 5 times y. So here's the pattern. 5 times y must equal 2 times x. I said this is the hard part. Danny, did you get that? Why is it the first one and not the last one? Because it looks like this one visually. We got to do 3 more. We're doing these. There's only 3 examples. So here's your second one. You ready? Once again, our goal is, given this and this, match this to one of these and then follow the pattern. So this looks like the first, second, third, fourth, or fifth. Anybody want to argue the last one?
No,
Why not the last one?
because there's only like 2 variables in there.
Well, notice on the bottom we have what? A whole bunch of things being added together. On our bottom we only have, notice on the bottom here we got one thing. So it's either second, third, or fourth, but on the top here you can see the addition going on. We've got addition going on. So it's kind of easy to see, well, at least I think so, that it should be, and most of you got it right, it's the fourth one. The hard part is the answer. So let's follow the pattern. It says take this, add it to this, and it's over this. So I go back to this one. It says x plus y over y. So here's the pattern. X plus y over y. See what my finger is doing? X plus y over y. X plus y over y. X plus y over y. Follow that same pattern that I literally just used my finger for. So that would be x plus y over y. I'm going to do the same tap with my finger. 5 plus 2 over 2. That's what you got to do. Where did I get that from? Well, I matched this pattern. And this pattern says x plus y over y. X plus y over y. So x plus y over y. X plus y over y. I'm going to do the same thing. 5 plus 2 over 2. So I write that down. Do a little bit of simplifying. We get to our answer. I'll have students that can't do this. You got to tell me if that makes sense. All I'm doing is identifying a pattern and continuing that pattern. Where does the x go?
The x
It's
is
still right here. I'm just
simple.
simplifying this part right here.
So all you're doing is basically plugging in the numbers. Like
I'm identifying the pattern and I'm repeating it on the other side.
Okay.
5 times y must be the same as 2 times x. All right, there's only 2 more left. See if you can get to it before I do. But I will walk you through it. Remember, we're trying to match the pattern to one of these 5 right here. First, second, third, fourth, or fifth. Okay, here's this one. Does it look like that? No way. Does it look like this? Does that look like this? Does it look like this? So it's either this one or this one, right? It's either the second one or the third one. Everybody tracking? So now we just see, well, follow the pattern. It says 2 over 5 here. Well, it said 5 over 2 here. So what did you basically do with this? You flipped it. So if you flip this one, guess what you're going to do with this one? It's the same pattern. If this one has been flipped, notice it's been flipped. It's the other one that has to be flipped. Which one is flipped? It's the third one. So what's the answer?
No Y over X.
It's y over x. You got to stop me if you didn't get that. I know I'm making a big deal about this. I said this is kind of medium. But for some kids, this is really hard. All right, last one. I said we're only doing 4 of these. And I already wrote the answer. Okay, so let's see. Certainly doesn't look like this. Certainly doesn't look like this. And it certainly doesn't look like this. I'm looking at this right here and trying to match it to one of these patterns. So this right here, once again, it's either going to be second one or the third one. Well, I got an x over 5. I got it. Well, the pattern looks like I went this over this. So this over this, I'm once again touching it with my finger. This over this, x over 5. If I do that same pattern, should equal y over 2. And by the way, that's the second pattern. Second pattern is a over c is equal to b over d. A over c is equal to b. A over c, b over d. All right, you tell me, yes or no? I'll get lots of kids have mistakes on this. In the big scheme of things, this is just identifying a pattern and following it with your finger, literally. Okay, I'll have a lot of kids make mistakes on this. All right, follow the patterns. The second thing I said was that we're going to do some more challenging proportions. All right, so a bit more pain, right? These are just algebraically a bit more challenging. All right, so look at box number 9. Box number 9. First one is kind of easy, medium. The second one is the more challenging. Okay, they're just a little bit of algebra. All right, Cadence, first one. What should I write?
Start 15x
Equals what? Equals
14.
14. Okay. I chose to write it in opposite order, but it's the same thing. So 14 is equal to 15x, therefore x is equal to, don't overthink it. You're done. Easy, medium, right? Bree, tell me what to do. Cross multiply. Tell me what to do. Just cross multiply. Tell me what to multiply. Okay, that's not a 5. 1 is 1. What's the other side? I said that's not a 5, even though I'm pointing to a 5. Why is that not a 5? Do the cross multiplication. Just tell me what to multiply. Yeah, why did you say 3 times 5? Why did you say 3x? Equals. No, equals the other cross product. There you go. Now do the distributive property. 2x what? Okay. Keep talking. Where are you getting 7 from? Where are you getting 7? You get rid of adding 10, you add 10 more? Okay, so on the right side you get, nope.
Negative.
Okay, therefore x is equal to, okay. Easy, medium, medium, the last one hard. No?
No.
Well, then tell me what to do.
Or 5x plus 10.
He's doing the distributive property already in his head. For the rest of us, we're going to say, okay, Jenna said it, equals. Now, for those of us who can do it in our head, go ahead.
It's 5x plus 10.
Equals.
4x plus Well,
Okay. I'm not saying you can't do it in your head. I mean, you are in geometry. I'm okay with that. Don't skip any more steps than that. But if you want to try to do it in your head, all right, go on with your bad self. You make a mistake, I'll hammer you. But absolutely, I'm not going to stop you from, okay, well, that seems ridiculous. Why do I want to write this when I know I can do that in my head? Although, Chandler, you did look for your fingers for 4 times 3.
yeah, I don't know multiplication tables.
Then why don't you try to do the whole thing in your head? All right,
So I
but,
use a calculator.
all right, well, Chandler, now tell me what to do.
Lives in exotic life.
Then, subtract 4x
X from both sides, and that would give us,
1x plus 10 equals 12.
therefore, X is equal to.
2.
All right, yay or nay? I'm not. I claim that was hard, but it's not really. They're not going to be any harder than that. They're going to move. They're not going to. They're not going to give you a quadrat. They could. They could. I mean, if this was 4x plus 1, then you're going to get a quadratic here. I thought that they would probably do it. They don't actually do that. So every single time, it's just a linear equation. So you don't have to deal with any quadratics here. All right, that's the whole class. But I do want to point out. It was 2 basic things. It was solve a proportion. Okay, that part's the easy, but it's this part, the matching the patterns that generally kick people's butts. You got to be able to remember all 5 of these. We'll get to the chapter test, and I'll think that I'll put a nice easy one like, I don't know, the 2nd or the 3rd one right here, and I'll have kids that still can't follow the pattern, right? So this has got to be in your book of truth, right? Guaranteed I'll put at least 2 questions on the and by the way, we're going to use this stuff in this chapter to prove things. Yeah.
On the midterms, can we use our book?
Absolutely. You have to.
Great.
There's no way you're going to remember 7 chapters worth of stuff, right? The nice thing about geometry, though, is most of the stuff we use so many times, like even though vertical angles is in your book of truth, you don't need to see that anymore because it's part of your being right now that vertical angles are congruent. Or the substitution property, you use it, or SAS, you use that so many times. Oh, by the way, we're going to get some theorems that are going to mess with that SAS stuff in this chapter.
Really?
Because we're dealing with similarities in this chapter.
Yeah.
All right, so that's finishing about, I don't know, 10 minutes early. So go ahead and get your books out and look through the homework.
More paid.
Wait, didn't we make a deal?
What was the deal?
If we had extra class time, like if you video that.
What was the video?
Music video.
What was it?
It's 13 Angels around.
No, that's not what I thought.
By Chop Suey.
I thought it was something other.
I don't know. It was just really on topic about.
No, we talked about something else we'd look up. It wasn't that.
It's like 13 Angels surrounding this player bed or something like that.
What?
I don't know. That's the name of the song.
Just get a bunch of pictures of Pokemon. I said Pokemon. I was like, wait.
Oh, we're not gonna look at a guy punching him.
Let's watch it.
You, 40 minutes.
All right, e-learners, any questions? Who we got here? Matt, any questions?
Not really.
All right. Matt, make sure you've turned in your homework that you owe me.
Okay.
All right, are you e-learning or are you just sick today?
I have an extremely bad headache.
Okay. Hope you feel better.
Thank you.
Buy me a PlayStation 5, Matt.